we know that in fifth lesson they are giving the different theories of light. One of the theory is Maxwell explained the wave theory. In that wave theory, it could not explain the photoelectric effect. So that was initially explained in the fifth lesson. So in these lesson I will explain that. So now that Unit 5 Maxwell explained the theory. So what are all the things he couldn't explain? That we are going to see now. So, the instant light is passed on the metal surface, that energy is given to the electron. After atomic applies, that energy is emitted from the metal surface. So, when the kinetic energy liberated electron, it is not depending on the intensity of the light. So, according to the Maxwell explanation, he explained that the energy is transmitted or the electromagnetic waves in a waveform. Light is in a waveform. So, that waveform energy is absorbed by the electron. After that, only the electron is emitted from the metal. So here, that wave is considered that energy is directly proportional to the intensity means when the intensity increases, the kinetic energy also increases. But the Maxwell experiment, when the intensity of the light is increased, there is no increase in the kinetic energy of the electron. So our increase one or intensity increase one. There is no change in the kinetic energy. So from that, we conclude that when the intensity is independent of the emission of electron. Already we know that from the experiment. The same thing I observed again. The next one, according to that wave theory, the sufficient energy is passed on the metal surface. The electron is liberated. So from the electron emission, after the incident light falls on the metal surface, immediately the electron does because after acquiring that, the energy more than the work function only the electron emits. So in possible only that electron emits more than the work function. Below that frequency, the frequency is below the threshold frequency, there is no emission of electron. That is also discovered by that Maxwell. I could not explain that wave theory. And then the light, the emission of electron is a large number. When that energy is given to that more than the work function. And it is an instantaneous process. There is no time lag between the incident of light and emission of light. அப்ப லைட் வந்து மேல விடுது அப்படின்னா immediately the electrons are emitted. There is no time difference. Okay. So that time period is 10 to the power of minus 9 seconds. So it's a very short time period. So it's an instantaneous process. Already we know the class of photoelectric emission. And then these are all the things observed by the Maxwell. He observed the photoelectric emission could not expect all the photoelectric properties. But Maxwell could not expect photoelectric properties. So that theory was discarded. After that, only that another theory was explained by the இலக்கியா கால் பண்றா 1 minute ஹலோ சொல்லுமா அப்படியா மியூட் ஆஃப் பண்ணி வச்சிருக்கா மியூட் ஆன் பண்ணு அப்படியா அப்படி வெளியில போயிட்டு திருப்பி உள்ள வந்து பாருங்க ஸோ இலக்கிய லைன்ல வந்தா சரி ஓகே ஸோ அவரால் என்ன பண்ண முடியல அப்படின்னா மேக்ஸ்வெல்னால எக்ஸ்பிளைன் பண்ண முடியல ஸோ தட் இஸ் அ போட்டோ எலக்ட்ரிக் எஃபெக்ட் ஸோ he could not explain the photoelectric effect. Next, the concept of quantization of energy. That was Planck was explained that quantum. The concept of quantum. So concept of quantization of energy. So failures of classical wave theory. Maxwell explained the classical theory, but it is failure to explain why it is independent of the intensity of that light, why that low frequency is not emitting the electron, and how it is immediately that electrons are emitted from the metal surface. That thing was not explained by the Maxwell. So next theory is explained by the Planck. Max Planck explained the quantum theory. So quantum theory, you know, the E is equal to h mu. That theory was explained by the Max Planck. So he explained that light is form of an energy packet. It is called quanta. It is a discrete energy level. Okay, matter is composed of a large number of oscillating particles called atoms. So here, that each atomic oscillator vibrates at different frequency. The frequency is emitting the different energy. That is E is equal to NH mu. Here, N is the number of electrons. That is the Planck constant and mu is the frequency. Here, the frequency mu is depending on the energy of the electron, right? Then E is equal to h mu. That is oscillator emitting that energy in the form of. So concept of quantization of energy. Max Planck proposed the quantum concept. So Maxwell could not explain the photoelectric effect. So Planck explained the quantum theory. That is quanta. He considered that light is the energy packet. It's called small energy packet. That's called quanta. That quanta is the light emitted by the electron which is oscillating inside the atom. That oscillating particles are emitting the energy. You know that different electrons have the different energy. So depending on the oscillation of that electron, it is emitting the different energy. So that energy also it will vary. He explained that energy E is equal to En equal to NH mu. So NH mu, where N is the number of orbital, that H is the Planck constant, mu is the frequency. Here suppose we give the N equal to 1, E equal to H mu, that is the energy. It's called quanta. That quanta possesses this much of energy. E equal to H mu. Right? So the energy of the oscillator quanta is the energy is not continuous. It's as believed in the wave picture. It's called quantization of energy. That means energy is not in the wave form. It's in the energy packet. The small amount of energy packet is called quanta. So here the energy is called quantization of energy. So in this method, the energy is transmitted, light is transmitted in the form of quanta. So that's what explained by the Planck. Okay. So particle nature of light, Einstein explained. So after Maxwell explained, Maxwell is the experimenter. He explained that energy is emitting in the form of energy packets called quanta. After 1905, Einstein explained the photoelectric effect of that energy packet that was explained by the Einstein photoelectric effect. So he got Nobel Prize in the year of 1905. So he explained that the frequency mu E equal to h mu. So it has a mass. It is the mass of NH packet. It does not have any mass, but it has the momentum P equal to h mu by c. Where P is called momentum, you know that. H is the Planck constant. Mu is the frequency. C is the velocity of light. So the individual light quanta has the different energy. It has a particular energy, different energy. So all the photons have the different energy. So the light is emitted in the form of photons, right? It is a massless particle, but it has the momentum because it's a energy packet. So light quantum is called photon. There are photon is nothing but the particle, manifestation of light. That means it's a particle. Here we consider that photon as a particle. So initially we explained that electromagnetic radiation that means it is an energy packet. The light is emitting in the form of photons. E is equal to hv. So what is the characteristics of the photon? So another character. So here the nature of light. Light is emitting the photon. It is radiated from the metal surface. That photon light of frequency mu. So the wavelength lambda will have the energy of E is equal to h mu. Here you know the one equation. C is equal to mu lambda. You remember that? C is equal to mu lambda.
Yes, sir.
C is equal to mu lambda, where mu is equal to
C by
by
lambda.
lambda. I understand, ma? C is equal to lambda. We get that. H mu. Instead of mu, you are substituting the C by lambda. Here, E equal to Hc by lambda. So that is the energy. Then next one is the next point, next character of the photon. That energy of the photon is determined by the frequency of radiation. So that light which is incident on the metal surface, it is depending on the frequency. Already we know that it is independent of the intensity of that light. So it is depending on only the frequency of that light, not intensity of the light. Next thing is photon travel with the velocity of momentum, because we consider that photon is a particle, all the particle definitely has the momentum. Momentum is mass into velocity. Here we derive the equation P is equal to h by lambda, or we can write lambda equal to c by mu. So we are writing here reciprocally mu by p. Do you understand, ma'am?
Yes, sir.
Okay.
Yes, sir.
Next thing, photons are electrically neutral. I told you that the photon is a energy packet. It does not possess any charge, positive or negative. It is electrically neutral. So that light photon does not affected by the electric field or magnetic field. It is not affected by the electric field or magnetic field. Then that for photon interaction. Interaction means that photon is passed on that photon, proton or the electron, some other particle. That means it's collide with the another particle. So definitely that quanta has the momentum. That means it has the mass and the velocity. So it has the momentum. So it collide with that another particle. Definitely it has the kinetic energy, potential energy, some other form of energy. So here the total energy, that means total linear momentum and angular momentum is conserved. So the linear momentum and angular momentum are conserved. So photon may be absorbed or new photon may be produced. This is the interaction. So the number of may not be conserved. So number of photons. Suppose one photon is falls on the metal surface, it can emit the two photon also or three photon also. But the total amount of linear momentum and the angular momentum is conserved. So single photon total momentum and emitted three photon momentums are conserved equal. Okay. It is not necessary to when one photon is falls on the metal surface, it should be produced only one photon. It may be two or three it is produced. But the total amount of linear momentum and angular momentum only conserved. So total amount of energy is conserved. Okay. So these are all the explanation of the science by quantum mechanics. Here the quanta was introduced by the Max Planck. That was explained by the Einstein. Where h mu is the 100%. That is h mu. That phi 0 is the work function. That is h mu naught. I wrote you nama h mu naught. That is work function phi 0. Remaining energy is
Kinetic
energy. That is half mv square. So when you add up that phi 0 and half mv square, you will get the total amount of energy. So the incident energy is two ways. It is used in the two methods. One is the work function. Another one is the kinetic energy. So now you can see that E is equal to h mu. That incident light is falls on the metal surface. Then the electrons are emitted. That another one thing h mu 0. Here mu is the one frequency. Mu 0 is the another one frequency. Mu frequency is greater than mu 0. அப்போ மியூங்கிறது அதிகமா இருக்கும், mu 0 கம்மியா தான் இருக்கும். Here mu 0 is the very less frequency or it is equal to work function. So the electron only come to the metal surface. It is not comes out. It is emitted. It is on the metal surface. Okay. Suppose we are giving that energy more than that work function. That electrons are emitted and it is moved with the kinetic energy. Right? So kinetic energy maximum. So what is the kinetic energy of the electron? எப்படி இந்த kinetic energy கண்டுபிடிக்கணுமா? Instead of phi 0, here you calculated phi 0 equal to h mu naught. This equation is substituted in this equation. Phi 0 equal to h mu naught. So that equation becomes, here you can see that h mu equal to h mu naught. Instead of phi 0 we can write h mu naught plus half mv square. So this equation is called Einstein's photoelectric equation. Right? So, and another one thing is, you know that electrons are revolved around the orbit in a different energy levels. Suppose this electron is emitted from the metal surface. இந்த electron மேல விழுகுதுன்னு வச்சுக்கங்க. இந்த electron மேல இருந்து வெளியில ஒரு electron. So we can consider that such electron is not collide with any other electron. It is directly come out from the atom. Suppose that electron is colliding with that another one atom, it will lose some energy due to the collision. So it lost some energy. So what will happen? We consider that electron does not collide with any other electron. So it comes with 100% of energy. that we are going to take as kinetic energy maximum, because it is not collided with any other electron inside that atom. So it comes out with the 100% of energy. That means it will come with maximum energy, kinetic energy maximum. So the velocity also does not change. That velocity also be maximum, right? So here we can write K maximum equal to half mv square maximum. So the maximum velocity of electron is ejected is equal to. So how we can write? So K maximum equal to h2 minus pi naught. h-ங்கிறது என்னது? ஏற்கனவே இங்க இருந்த ஈக்குவேஷன் தாமா. Do you understand that? Here h mu you know.
Energy.
Yeah.
Let's call the frequency. Here you know the gap. Already I told you, now remember that. This much
sir.
of energy, that line is not starts from the zero. It's only starts from here. The reason is that small amount of energy. Here you can see that line, the negative line. This much of energy is absorbed by the electron to comes to the metal surface. After remaining energy only, it has the kinetic energy like this. So it will get emitted from the metal surface.
Metal surface.
That is the green color line. That green color line is the kinetic energy of the electron. The red color line is the work function, negative energy. That energy was absorbed. That's why it starts from zero here. Otherwise, it will start from zero. So it's some distance is there. That much of energy is absorbed by the electron. Okay, that was explained in the graph. Cesium material is cesium, potassium, sodium, lithium. These are all the photoelectric emitting material. So using that, they have studied the graph. See, here cesium, potassium, and sodium, calcium is here. Cesium has the low work function, minus 2.14 electron volt. Gradually, the work function is increases for potassium, sodium, and calcium. Already we know that these are in the timetable. Remember that? Table.
Yes, sir.
Okay. So here H is Planck constant. You know the value of Planck constant. 6.626 in 10 to the power minus 34 joule seconds. Then explanation of photoelectric effect. Again the same thing. Already we know that 4 laws of photoelectric emission. Again we are going to explain the same thing. As the instant light photon emits the one electron, frequency E equal to h mu, that is the photon. When it is passed on the metal surface, that electrons are emitted. Depending on that energy of the incident light, the electrons are emitted. But it is independent of the intensity. So increasing the intensity of the electron light means we have to increase the frequency, not in the intensity. Next thing, kinetic energy maximum equal to h mu minus pi 0. So here it is evident that kinetic energy maximum proportional to the frequency of the light and independent of the intensity. Here also there is no intensity. We are not mentioning that any instant intensity. So it is independent of the intensity of the light. Already we know that. The next thing is that energy of the electron. Suppose that energy of the electron, instant light is below the threshold frequency. There is no electron is emitted. Then the energy is more than the threshold frequency or high frequency only, above the threshold frequency only, that electrons are emitted. That is called photoelectric emission. Below that frequency, there is no electrons are emitted. Next one, according to that quantum concept, transfer of photon energy electron instantaneous process. There is no time lag between the instant light and the emission of photon. That is also explained in the same experiment. Next thing is the nature of light, wave, particle, duality. So we have learned that in electromagnetic radiation, it has the interferences, diffraction, and polarization. So it is behaves like a wave. In some other circumstances, that black body radiation, photoelectric effect, it is behaves like a particle. Right? In the past, many scientific theories, it is not explained by explain the light properties of that light. So that theories, all the theories are discarded. After Maxwell explained that wave theory, that is also not explained the photoelectric effect. After That photoelectric theory, that quantum theory explained by the Planck, and that idea given by that Einstein successfully explained that particle nature of the light. So here we concluded that in some other circumstances, light is behaves like a wave. In some instances, it is behaves like a particle. So wave, we can suppose we consider that the light wave is a wave, electromagnetic wave means it is propagate. When we consider the propagation, we consider light is a wave. Suppose in interaction, then one electron is collided with another electron, like that, then the photon is interacted with that electron. Interaction, we consider that is a particle. So the light has a dual nature. In wave form and wave, we consider that propagation. Interaction, we consider the particle. So this is the dual nature of light that was explained by the Einstein. Right? The theory was proposed by Max Planck.